Good afternoon, everyone. I know it's a little late in the day, so thank you for joining. Really appreciate it. My first time actually at the JEC, so really excited to be here. My name's Ross Key. I work for SYENSQO. I'm an applications development engineer based out of the UK. And today I'm going to be presenting to you on composite solutions to meet the current and future needs of the advanced air mobility market. And I've been told that there's actually a speaker area if anyone wants to dive into the detail. This is going to be a relatively high-level presentation, so look forward to answering any questions after the session as well. So before we get into the sort of the technical aspects, just wanted to touch a little bit on the history of the company. SYENSQO is a relatively new name to probably most people here, but it's built on a long foundation of innovation. Starting off with the 1911 Solvay conference, which brought together some of the greatest minds in physics and chemistry, and that really is at the core of our SYENSQO ethos today, and continues through a lot of the work that we do. So this slide kind of shows the history of SYENSQO. Many of you. So starting off with its legacy in Fiberite and working through sort of a number of companies since then, from ACG to Umico, Cytec, and Solvay. SYENSQO is really the sort of progression of those companies which have offered an awful lot in terms of the development of composite materials for this industry. And as SYENSQO, we aim to really push that, focusing on areas of lightweighting, hydrogen propulsion, sustainability, and electrification to really leave our mark on the industry moving forward. So in terms of the presentation, what we're going to cover today is the potential impact of the advanced air mobility space on the composites industry in general. What does the path from certification to rate look like? This slide. What the path to certification to rate looks like, and how we intend to tackle the high rate production aspects of full rate. And certain applications will pose a greater challenge than others, and we aim to sort of tackle that with material and technology solutions. So the chart on the left basically shows the projected number of eVTOL deliveries from 2030 through to 2050, and you can see that's almost increasing exponentially with time. So while the actual market size and timing is relatively unclear, what we do know is that this particular market is going to be transformative to the composites industry, and we need to make sure that we've got materials and processes in place to satisfy the future needs. In terms of where we are in the market today, the chart on the right-hand side shows three phases: initial prototyping, certification, and low-rate initial production, and then full-rate production, which comes much later on. In terms of the OEMs within this space, most are currently between the prototyping and certification phase, with early entrants targeting certification by 2025, and significant progress is being made towards that. So in terms of the vehicle itself, advanced materials are used across the entire eVTOL vehicle, from the airframe to the rotors, interiors, battery enclosures, and e-motors. So a diverse material portfolio is needed to satisfy the needs of those various different applications, which vary significantly in terms of performance and rate needs. SYENSQO has probably the most diverse material portfolio on the market today, from liquid molding, thermoplastic and thermosetting prepregs, surfacing products, adhesives, and specialty polymers. And as such, we've signed multiple agreements with advanced air mobility OEMs in this space and are actively working in this area today. So in terms of the various production stages, prototyping and certification have relatively similar requirements. customers are looking for products with a legacy, high performance to minimize weight, available data to de-risk, and flexible cures to take advantage of more traditional manufacturing methods. This holds true through to certification as well, but as we tend towards low-rate initial production, there is a desire to move towards automated deposition technologies, whether that be advanced fiber placement, tape laying, or pick and place, to really help bridge that gap to rate. And again, we're actively working on all these areas really to help support our customers. As we move towards the high-rate production phase, the requirements change quite significantly. And although performance and lightweighting are still key, there's going to be more of a focus on things like rate capability, total cost of ownership, and then an integration of multi-material solutions to find the best material and process technology for a given application. And sustainability is also going to be a big piece as well. Clarity on the rate and performance needs for a given application are key to ensure that we select the right material and technology fit. But SYENSQO is actively working on a number of technologies that are really going to help support this move to high rate in this market, from press cure, including SYENSQO's double diaphragm forming technology, stamp forming with thermoplastics, resin infusion, and injection molding as well. So the chart on the left is basically a breakdown of number of parts per annum on the left-hand side, and compares sort of the larger part volumes in large commercial transport. The example given on there in the star is the LRIP fan blades. And then the various different production phases from prototyping and certification in the middle, low-rate initial production, and then full-rate production on the right-hand side. And you can see, specifically with certain applications, including rotor blades, high-rate structure, which includes ribs and frames, and battery enclosures, where the parts can be 10 up to 30 parts per vehicle, that the parts per annum can increase quite drastically as we tend towards full-rate production. So it's these particular applications that are going to pose a specific challenge, or more of a challenge, for composites manufacturing. So the next 3 slides really focus on the rotor blades, the high-rate structure, and the battery enclosures specifically, and what SYENSQO is doing, or products that are available to really help support the transition to high-rate manufacturing for these specific applications. So in terms of the rotor blades, we've got a number of legacy products. SYCOM 381 is a pre-preg 1.5 hour 120C curing system, which has a long legacy in blades manufacturing. More recent products, 2 hours 180C cure, more traditional aerospace systems with NCAP databases to help de-risk. MTM45-1, which I believe has the most extensive NCAP database of any pre-preg material. And more recently, a newer product, SYCOM 2190, which is an autoclave curing system, which we work on an NCAP database as well. So these all help customers move from the initial prototyping phase through certification into low-rate initial production using legacy manufacturing processes. But as we tend towards higher rate, processes like RTM with SYCOM 823 will probably become more beneficial due to the part complexity and net edge requirements of the blades. But we're actively working on a number of technologies, including press curing of existing qualified systems. So there's a possibility to use the same material from the prototyping phase through to high-rate production, with takt times in the order of 20 minutes to sort of tend us towards the higher volume of parts. And also on high-rate sandwich structure development as well, and the compatibility of our pre-preg systems either in or out of the press, with different cores, adhesives, and surfacing as well, to ensure that we have all the information that's needed for the customer to transition to rate, and the compatibility between these different products as well. So in terms of high-rate structure, some of the same systems apply. MTM45-1 and 2190, and some of these systems are being actively used today in this space. But one of the more recent developments, which might have a big play, is a system called EP2750. It was designed specifically for high-rate primary structure with a focus on press cure. And we're currently running NCAP qualifications on 2 product forms, the 8-harness Satin and a 2x2 twill at the moment. So those databases should be ready for when customers need to transition to that high-rate phase. As well as the activities on press curing existing systems like 45-1 to prove out their rate capability and enable bridge qualifications from historical data sets on oven or autoclave curing to press curing as well. Thermoplastics will be key. We're actively working on products on APC PEC for these structural applications as well. And I mentioned on the previous slide the compatibility for multi-material solutions and high-rate assembly with Aerospace 1006, fuse ply products 250 and 350, which are 120 and 180C curing systems, as well as surfacing and adhesives as well. So battery enclosures is the last one. SYENSQO has a broad product portfolio to support battery enclosure manufacture with legacy solutions in FR epoxies, phenolics, BMIs, and cyanide esters. But we appreciated that there's going to be a need for a high-rate solution that is really in line with the requirements of this market. So XEP 1710FR is a fire-retardant epoxy system. It comes on a number of different reinforcements, glass and carbon, different weights and weave styles. It's actually achieved UL 94V0, self-extinguishing, at a number of different thicknesses and product forms as well, and passes the UL 2596 thermal runaway test at 2 mil thickness on carbon and on glass, which is unique to this product. It's 10 minutes press cure capable, so it really aligns with the rate piece for full rate production. And we're actively working on compatibility with core materials, adhesives, surfacing, and there's a number of active projects ongoing with customers at the moment to really prove this out for the future. In terms of alternatives, Everlight TPC is another product that we're actively considering, and there's significant development work ongoing on that as well. So there's quite a lot of information, I'm sure, as you can appreciate on this slide. I won't go through it all. But really, the key takeaway is that to be successful in this market, we really need a holistic approach to supply chain and supply chain management. So starting with the design and a design for manufacture approach, selecting the right material and process for a given application, where multi-material solutions are going to be a key enabler for success for high rate. So to summarize, the composites industry is likely to experience a transformative change due to a number of markets, but air mobility is going to play a significant part over the next decade. For certification, prototyping certification, and for low-rate initial production, existing materials and manufacturing processes are going to be suitable, but as we transition to much higher rates, new materials, new processes, the compatibility between those are going to be key in order to be successful moving forward. And SYENSQO is actively pursuing material and technology developments in this area already, but are open to partnerships to really make sure that we have the right materials and processes in place to be successful in the future. Thank you very much for your time. Really appreciate it. If anyone would like to ask any questions or join me in the speakers area, I look forward to speaking to you then. Thank you.